So some information about the DHCP server. It's a dynamic host configuration protocol. It's where a network protocol takes an IP address and assigns another address from a range of addresses that you determine. You can go in there into the configuration file and determine what addresses from, like, say your IP address is dot or 92 or 192.160.10, you could assign that the next dot to like 60 or something, and then from 60 to 70. And it also assigns a submask and a default gateway and a DSN address, like you can use Google's or any website really. But I just chose to use Google. It saves time with the TCP networking settings and maintenance too as well. Some of the benefits for your network: it manages manages the IP addresses. It centralizes network configuration, network booting, large network support. It reduces operation tasks. Promotes mobility of devices when connecting from different places. So if you wanted to take like your laptop and you're moving to another office in the building or another floor, as long as you're connected to that DHCP server, that was the host was, let's just say it was in Dallas or in another state, you could still be on that same network and be able to communicate with everyone around you, no matter where you took it, even if you took it home. The client connection, say if they need to restart their device, it won't just shoot out another IP address that's random. It'll have an assigned IP address given to them. And if they happen to just disconnect from the network for some odd reason, it'll still have it in memory that, okay, you were using this IP address, I'm going to shoot it back to you. It provides a time. What it does is it provides a time lease for the IP address, and those can be managed as well. In one of the settings, at the very end, whenever you're setting up your initial how it's working, you can determine, like, but with a /12 or a /2h for the amount of hours that you're actually using that IP address for each device. So it helps with any IP usage extensions. So functionality and how it really works in the architecture. The device requests the network parameters from the DHCP client when joining any network. When it's assigned a static IP address that's already configured in that network, then they'll be able to communicate freely with their devices, and that includes any of the IP address, the net mask, the default gateway, and the other domain name and server. It's a client-server architecture, and in this case, the DHCP client uses the UDP port at 68, and the server, wherever that is, it could be anywhere at a different site, uses port 67. The clients aren't initially set up with an IP address. It must ask the DHCP servers for a broadcasting packet, and that packet shoots over all that information: the address, the mask, the gateway, and the name and domain name and server. And like I said before, this is done in a lease amount of time from a pool, and you're able to actually extend that pool. You're able to go in there and extend and say, hey, I would like to use this IP address for 2 more hours, 3 more hours. And you're able to extend it. You're able to stop it and ask for a new one. That's their functionality. This could be used in any future application, career applications. Say you're a network administrator, and having that DHCP server could greatly limit the amount of time it would take for you to determine the IP address of a device that needed to be restored. Say if there's a hard drive failure in that device, you needed to find out the IP address of that device before you actually rebooted it and restarted it and everything. It could cut down a lot of time, because there could be hundreds of devices that were being handed out, or even thousands that are being handed out by this one, by a server or a network or a router. But if you had that DHCP server, you would know exactly what IP address and what net mask was being used on that device specifically. So it would save you a lot of time and a lot of headache. With the static IP address, you can check which device is assigned to and what device, a list from it keeps a list is what it does. And this helps so the device is not given the same IP address over the same period of time. So in any, say if you didn't have this, your router is giving you one IP address, and then say if you had like an extension of like a wireless node or something that was giving you another IP address, the DHCP could just say, okay, no, you're not doing it. This IP address is going to take precedent over any other device that's handing you out all these other IP addresses. So it cuts back on any collision of IP addresses from different devices. So in a workstation setting, when someone leaves and closes the workstation the next day, they don't have to have like this brand new IP address. They can be assigned the same IP address from the previous day, or if they had to leave to close down for lunch, they come back and it's still the same IP address that they had initially with that time lease and that time stamp. So it's easier to keep up with them. Thank you.